Good morning, dear students. Yesterday we have discussed about the algebra various portions, right? In algebra we have studied quadratic equations. We have studied quadratic equations, how to find their roots, the nature of roots. Then we have studied also simultaneous equation, how to solve these simultaneous equations, and we have also studied inequalities. We have also studied about the polynomial. Today we will start the new topic, chapter number 3. Start chapter number 3, coordinate. Coordinate geometry. So in Jaswinder, very good morning, bache. In coordinate geometry, in the book they have explained each and everything. First, they have discussed that how to locate a point on a plane. To locate any point in a plane. We know to locate any point on a plane, we divide the plane in 4 quadrants by two mutually perpendicular lines, x-axis and y-axis. The horizontal line is your x-axis, and this is your x dash, and the perpendicular line, that is, we have studied in our lower classes also. So here it is your first quadrant. This is second quadrant. This is third one, and this is the fourth one, right? So in the book also they have explained in the same way the quadrants 1, 2, 3, and 4, and the points, the naming where these 2 points intersects. That point is called origin, 0 and 1, 2, 3, 4, 5, so on. 1, 2, 3. It's the naming. -1, -2, -3, -4, so on. -1 this side, y-axis. So y-axis negative, y-axis positive this side. So on. So if any point P, abscissa and ordinate, right? If any point P, x, y is denoted by x, y. So point, suppose here point P, x is 3 and y is 4. So x is 3 units here and y is 4. X is 3 and y is 4 here. This is the point P here. So point P can be in any of the quadrant. In second quadrant, x will be negative, y positive. Third quadrant, both x and y are always negative, right? And fifth, first is positive and y is negative. Right? Here both they are positive. and in here it is negative, y is positive, right? So this is about your or plane. So everything, every point on the this plane is denoted by a point x and y. X and y are the coordinates. Okay, x is called abscissa and y is called ordinate. Now next, what they have discussed here, they have discussed here plotting and sketching and drawing, and then they have started with the gradient of a line. That is, next is the gradient of a line. If we have a line, we have studied in previous class, that is gradient of a line. Gradient of a line. Gradient of a line. If P and Q, if P and Q are P and Q, like x1, y1, and Q, x2, y2, are 2 points on a particular line, are 2 points on a particular line, then the slope or the gradient m is always equal to y2 minus y1 divided by x2 minus x1, right? If we have a point P and Q lies on the line, then the gradient of a line is defined as y2 minus y1 upon x2 minus x1, right? If we have a point A and B, A points is 2, 4. If A point 2, 4 and B point is 6, 7, then the slope here that is 7 minus 4, 7 minus 4 and 6 minus 2. So it is equal to m is 3 by 4. The gradient is 3 by 4, right? The gradient is 3 by 4. So next we have the same form on the both axes. M is also defined as tangent of theta. This m is also defined as tangent of theta, right? The gradient or the slope that is also tangent of theta, because generally we have, if we have a x-axis, y-axis, right? And suppose if this is a line, so here A point, suppose A is your 2 and 4, and 6 and 7 here, B is here. So this side perpendicular upon base, perpendicular base is your tangent of theta. So slope of the tangent, that is also defined by tangent of theta, right? Tangent of theta is equal to m, that is called the slope or gradient of a line, right? This is called the gradient of the line. So here we have different slope. If line is in this way, suppose line is in this way, then the slope of the line is negative, right? If line is parallel to x-axis, then slope that is 0, and if line is a perpendicular line, the d has an infinite gradient. If any line which is perpendicular here, suppose this is a line perpendicular to x-axis, then we are saying the slope or the gradient is infinite the line is having the infinite slope, and here if it is line is parallel to x-axis, then it is having zero slope. I hope it is clear because we have studied in our previous classes also. So next topic, that is two lines parallel and the perpendicular lines. When two lines are parallel to each other and the two lines are mutually perpendicular to each other, in that when two lines are parallel to each other, when two lines when two lines are parallel to each other, parallel to each other. So we know when the lines are parallel to each other, then their slope is what? Slope is same. If the line, one line is having slope m1 and another is having slope m2, in that case, when the line are two lines, if they are parallel to each other, two lines, if they are, this is slope of line m1 and slope of line l2 m2, then always what we have, parallel lines, in case of parallel lines, slope m1 is always equal to m2. In case of two parallel lines, confirmed their slope m1 is always equal to m2, right? And when the lines are mutually perpendicular to each other, right? This is case 1, case 2, when the lines are, the two lines are mutually perpendicular to each other. When the two lines, they are mutually perpendicular to each other, means if one line is, another is, one slope is m1 and another slope is m2, and here the angle is 90 degree, in that case always m1 into m2, right? What is, we have also studied that in that case m1 m2, the slope of these two, product of the slope of two is always equal to minus of 1, right? So we have studied in the previous classes also that when the two lines, they are parallel to each other, then their slopes are equal, then m1 is equal to m2, and when the slope of the two lines, they are, or the two lines, they are mutually perpendicular to each other, when the two lines, they are mutually perpendicular to each other, then the product of their slopes or the gradient, that is minus of 1. Okay, so next one, we will study the distance between 2 points, right? Here we have one activity is there, right, regarding the gradient m1 m2 lines, when lines are parallel and when lines are perpendicular to each other, right? So the scale, same scale has been used in both the axes. Okay, so distance between 2 points, topic is the distance between the 2 points. the distance between 2 points, the distance between 2 points the distance between 2 points, this is called your distance formula. If we have 2 points, like one is your a x1 y1 and b point x2 y2, in these cases, when the distance AB is always equal to under root x2 minus x1 whole square plus y2 minus y1 whole square, right? This is the distance formula. As we have taken the example, if A point is 2 comma 4 and B point is 6 comma 7, right? So here, when we plot it on both points lies on your y-axis, and between on first quadrant, this is x-axis, and here it is y-axis. Y-axis. So here, if one point is 2 and 4, and 6 and 7, this is a line. One is the point 2, 4, and B is the point 6, 7. So here, how we have found A. This is your, one is abscissa, one is ordinate. 3 units. Sorry, 2 units. Six, 4. So here, what is the distance? This distance is here, that x2, that is 6 minus 2 whole square, and here this is the y, that is 7 minus 4 whole square. So distance formula here, the distance AB here, that is x2 minus x1, right? X2 minus x1 plus y2 minus y1 whole square. So x2, that is your 6 minus 2 plus 7 minus 4 whole square. So we have here 4 square, that is 16, and 3 square is 9. This distance is 5 units. This distance AB distance, this is 5 units, right? If these are the points, the coordinates, that one is x1 y1, one is x1 y1 and another is x2 y2. So we have x2 minus x2 minus x1, 6 minus 2 whole square plus 7 minus 4 whole square, that is equal to under root 25, right? So this is the distance between 2 points, right? And then we have one more formula, that is called your midpoint formula. Midpoint formula. Then we have the exercise also, midpoint formula. Midpoint formula. If we have 2 points, one point is A and one y1, right, and B coordinates, then the midpoint M is the midpoint, then the coordinates of midpoint X and Y are, right, the coordinates of midpoint M, X, Y. X is equal to x1 plus x2 divided by 2, and the coordinates of y, they are same, y1 plus y2 divided by 2, right? So these are the x and y are the coordinates of the midpoints, where M is the midpoint of any line segment AB. If A and B are the points, AB is x1, y1, and B is x2, y2, then the midpoints are always x1 plus x2 divided by 2 and y1 plus y2 divided by 2, right? This is about your midpoint formula. So if we have some questions here, taking A 2, 5 as the point, uh, find the gradient, length, midpoints, or each and everything they have asked with the point A is 2, 5 and B is 6, 3. Now one question they have discussed, if a point A is 2, 5 and B point is 6, 3. So here first find the gradient. Second, find the length AB. Find the midpoint of AB. And one more they have asked. They have asked the gradient of AB, that is asked. Okay, right. Gradient of AB. So here, gradient of line perpendicular to AB. Gradient of line gradient of a line perpendicular to AB. So start doing. First is the gradient. Gradient we know y2 minus y1, y2 minus y1 upon x2 minus x1. So which is equal to, here y2 3 minus 5. 3 minus of 5 divided by 6 minus of 2. So here we have, that is minus of 2 upon 4. So which is equal to minus of 1 by 2. What is the slope of the line? Minus of 1 by 2. So next we have the distance formula AB. The distance AB is equal to 3 minus 5, 3 minus 5, 2 minus 2 whole square. Sorry, uh, first x 6 minus 2, 4, 4 whole square is 16, and next is your 3 minus 5, 2, 2 whole square is 4. So we have under root 20. The distance is under root 20, which can be written as 2 under root 5 units. Now midpoint of AB. Midpoint of AB, the coordinates of the midpoint, that one is x and y. So x is 2 plus 6 divided by 2. 8 upon 2, that is 4. X is 4 here. And y is 4. So midpoints, the midpoint is having coordinates 4 comma 4. Y is also 4. Right? So here, what are the coordinates? 4 and 4. Now here we know m1, m2 is minus 1. Gradient line perpendicular to AB. m1 into m2 is equal to minus 1. So if one gradient, that is minus of 1 by 2, m2 is equal to minus 1. So here slope of m2 is equal to minus will become plus. Slope of the line is plus 2, right? So this is about this question here. We have one more question, that two different methods of showing the line P and R from form a right angle triangle, right? Here we can apply the distance formula. 3 points are given. They are saying show that the line joining show that the line joining show that the line joining P 27 Q 32 and R 05, right, form a right angle triangle. Formed a right angle triangle. Formed a right angle triangle. Here 1.27, 32 and 05. So we know Pythagoras theorem holds. We can find the distance formula. One is PQ, one is QR, and one is PR. So PQ here is 3 minus 2, 1 whole square, that is 1, plus 2 minus 7, that is 5, 5 square is 25. This distance is under root 26. QR, QR again here is 0 minus 3. 3 whole square is 9 and 9 plus 9. Because again 5 minus 2 is 3, 3 whole square is 9 and root 18. And PR is 0 minus 2, 2 whole square, that is 4, and 2 whole square is again 4 and root 8. So here under root 8, under root 18 and under root. So here we will check here that 26 under root 26 whole square is equal to under root 18 whole square plus under root 8 whole square, right? So here we have square is 26, and this implies that therefore we can say therefore triangle PQR is an right angle, is an right angle triangle, is an right angle triangle, is an right angle triangle, right? So this is about the 3 points, given 3 points. They, when we plot the diagram on the Cartesian planes, we will find that the triangle is a right angle triangle, right? So next one, next we have now the exercise, a complete exercise having 11 questions based on the distance formula. First one is the following pair of point A and B, calculate the gradient of the line, midpoint, distance, gradient of the line parallel to. So let's take few questions, few 2 or 3 parts. Here they are given 9 parts. 9, 1, 2, 3, 4, 6 parts are given. Okay, let's take two parts here. So exercise chapter 3, we can take two parts. One we can take the last part and one we can take the first part. First part is question number 1. First part, that is 0, 1, and B here is 2 minus 3. And the sixth part, A is 1, 4 and B is 1 minus 2, right? So here all 4 things we will find. We will find first the distance between the 2 points, or first we will find the gradient or slope of the line, then the distance between 2 points, then the third one, that is the midpoint, and fourth the line perpendicular to the given line. Okay, so let's begin here. First one is the coordinates, the distance AB, sorry, the gradient. The gradient is y2 minus y1, y2 minus y1 upon x2 minus x1. So it is equal to y2 minus y1, minus of 3 minus of 1 divided by 2 minus 0, right? So here what is the gradient? Gradient that m is equal to minus of 4 upon 2, so it is equal to 2. So what is the slope? Slope m is equal to minus of 2. Next, we are interested to find, this is the part A, part B, the distance formula. What is part B? The distance formula. We have to find the distance AB. So distance AB is equal to x2 minus x1 whole square plus y2 minus y1 whole square, right? So here we will substitute the values. When we substitute the value, that is x2, 2 minus 0 whole square, 2 minus 0 whole square plus minus 3 minus 1 whole square. So here we have one is 4 and one is your 16. 16, 4 into 4, 16. So here the distance, that is under root 20. What is the length of AB? Under root 20, or we can write it as 2 under root 5. 5 units. This is the distance. Next is the midpoint formula. Midpoint formula say one is 1 and another is the midpoint. One is 0 plus 2 divided by 2, that is 1, and 1 plus minus 3, minus 2. Minus 2 upon 2 is again minus of 1. This is the midpoints. So midpoints of the line segment AB are 1. And the last D part, that is regarding the gradient of a line parallel to. So here we have M1 into M2 is equal to minus 1. What is M1? We have found minus of 2. It is what? Minus of 2 here. So what is M1, M2? M2 here is minus minus will get cancelled and it is 1 by 2. The slope of a line which is perpendicular to the given line segment AB is 1 by 2. Right? In the same way, slope here is y2 minus, so minus of 2 minus of 6, sorry, minus of 4 divided by 1 minus 1. So here it is slope is minus of 6 divided by 0. So here anything number divided by 0, that is what? Infinite, right? So here the slope is infinite. This line is, if we plot the point, one is 1 4, if one point is, this is 1 and this is 4 here, and another line that is again 1 and minus 2, 1 and minus 2 here. So slope here, slope of the line, slope of a line is infinite. Slope of the line, that is infinite, because minus 6 upon x2 minus, sorry, y2 minus y1, minus 2 minus 4 is 6 and 1 minus 1 is 0 here. So slope of this line segment AB is infinite. Next we have to find the distance AB. The distance AB is equal to under root, that is x2 minus x1, 1 minus 1 whole square plus y2 minus 4 whole square. So 6 6 are 36. So here it is what? 36. So the AB, what is the AB? That is 6 units. Midpoint midpoint, so midpoints are midpoint A and B. So midpoints, the coordinates, the abscissa axis 1 plus 1 divided by 2, that is 1, and y, that is minus of 2 plus 4 divided by 2. So here is, that is also 1, right? So what are the coordinates of the midpoint? Midpoint coordinates are 1 comma 1. 1 comma 1. Here it is 2 upon 2 is 1 only. And the last one, here the slope of the line, slope of it is infinite, slope of a line perpendicular, that is always 0. Slope or gradient of line parallel to, because m1 m2 is equal to what? Minus 1 here. So here m1, if it is 1 is infinite, right? So minus 6 upon 0 into m. So here m2 is, so slope of the line, that is 0, right? If a slope of a line we have to find which is parallel to the another, so its slope is 0, right? So in this way you can solve the exercise. It is having total 11 questions. So based on first we have studied, let's recapitulate again what we have studied. We have studied first the gradient in previous classes also we have studied. Gradient of a line is equal to y2 minus y1 divided by x2 minus x1. That is the gradient, or called the slope of the line. So we have studied the slope of the line, that can be positive, that can be negative, that can be infinite, or that can be 0. If a line, this is a line here, if its line is parallel to x-axis, then its slope is 0. And if the line is parallel to your x-axis, its slope is 0. If line is perpendicular, its slope is infinite, right? And the slope is y2 minus y1 divided by x2 minus x1, right? The slope of a line can be 0, positive, negative, or infinite, right? M denotes for the slope, and this M is also equal to your tangent of theta, right? Because tangent of theta is also equal to perpendicular upon hypotenuse, right? So tangent theta, it's defining the slope of the line. Next is distance formula. So distance formula is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. With x component, with the abscissa, we will subtract the another abscissa and ordinate the another ordinate and take under root. So square of this will give the distance between the 2 points. Then third, the midpoint formula. If 2 points are given in the Cartesian plane, like one point A, its coordinates are x1 plus x1 comma y1, and the another point B, its coordinates are x2 comma y2. Then the midpoint of these 2 points is always equal to x1 plus x2 divided by 2, and y is equal to y1 plus y2 divided by 2. These are the coordinates of the midpoint. And the last one, which we are doing in all the questions, if two lines are parallel to each other, then their slope is equal. And if the two lines, they are mutually perpendicular to each other, then their slopes, product of their slope is minus 1. M1 into M2 is equal to minus of 1. So this is all for the today's class, right? So stay safe and stay happy and work hard. So with this, I'm going to end today's class. So thank you very much.